Hi guys, welcome to Naresh Technologies. This is Subbaraju. Last video session continue with the file permissions with umask command. User masking. Using umask command, we can assign permissions at user level. What are the permissions we can able to apply? What is the umask working principle we can try to observe. User masking is a command to apply permissions file as well as user level. These are the two components we can try to perform. Umask default nature we need to understand first. So file level it is behaving differently. Directory level it is behaving differently. File level umask default permissions are 666. Directory level umask permissions are 777. Whenever you are using umask, there is a mode you are assigning. For example, you assigned 424. Umask mode is 424. The mode you need to minus from the default. Then whatever you are getting, that is a real permission. Right, file default is 666 minus 424 and directory default is 777 minus 424. So whatever the answer you are going to be, 6 minus 4, 2, 6 minus 2, 4, 6 minus 4, 2. You got here 242. Again we will try to calculate in detail this 242. And again we can observe here 7 minus 4 is 3. 7 minus 2, 5. 7 minus 4, 3. So directory level permissions are, you got 353. File level 242. So first 2 representing owner of the file, 4 representing group of the file, 2 representing others of the file. Here directory level 3 representing owner of the file, 5 representing group of the file, 3 representing others of the file. This operation in detail we can see with calculations. Right, 242, 353. First, as I said already, user level, 4 group level, 2 others level. 2 binary number 0, 1, 0. 4 binary number 1, 0, 0. 2 binary number 0, 1, 0. RWX, RWX, RWX. Specially no need to explain. In the previous video session, I made very clear regarding read, write, execute. No read permission, write permission is there. No write execute permission, that's all. Hyphen W hyphen. Read permission available. No write, no execute. No read permission, write permission is there, no execute. So if you are creating a file after 424 chmod, you are getting owner level write permission, group level read permission, others level write permission for a file. We will see in the directory, then practically we can see. 353 same. First one is owner, second one is group, third one is others. Now 3 binary number 0, 11, 5 binary number 101, again 3 binary number 0, 11. RWX, RWX, RWX. No read, write, execute. No write, read, execute. No read, write, execute. So these are the permissions for directory. So by default 666, 777 and directory level permissions, file level permissions available. These permissions, how we can able to apply practically? Practically we can observe that umask just enter, it is showing by default the 0 is ignore and remaining 3 digits you can take owner as well as group and others level available 002. So means if you are going to create 666, 777 formula we can see. Now I am creating a file cat, file name is for example hello, it is a hello text file and control D save and exit, ls-l long listing format, RW for owner, RW group or only for others. Why the permission is like this? Just go to 666 available, 666 minus we need to do that 002. So 6 minus 0 6, 6 means read write, again 6 minus 0 means 6 read write, again available 2, that means 6 minus 2 4, 4 is nothing but representing read permission, perfectly it is working. For example umask I want to change, umask I want to remove first all my files from the current directory, there is no file available right now, I am taking umask as my example is 424, press enter. Now I want to create a file by using any command touch, I am creating a file linux, yes ls-l, my previous calculation already shown and that calculation write, read, write, write for owner, read for group, write for others, because 666 minus 424, then you are getting whatever the permission 2, 4, 2. Now directory level we can observe mkdir, I am creating a directory is nothing but Paul, press enter, ls-l, yes, write execute, small d always represent directory, read execute, write execute. So these are the permissions at the directory level because 424. For example, we'll try to observe with another one, remove all the files from the current directory area, and once you are removing and I am creating umask, once umask, if I say 000, if I press enter, then I am creating touch and I am creating another file, one color I am giving yellow, right, ls-l, because 6 minus 0 6, 6 minus 0 6, 6 minus 0 6. So RW, 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 no execute to any user. Next we can come down to mkdir. I am creating mkdir and I said for example red directory, ls-l, exactly whatever you expected because 777, so automatically 777 available, read write execute, read write execute, read write execute. Right, again finally for your confirmation purpose a perfect command I am executing. What that ones? umask 777, press enter. Yes, once you are giving like that, and if you are going to create a touch and I said for example hi, ls-l, yes, as you expected, no permission because 7 minus 7 minus 7 minus 7 minus means 7 minus 70, 7 minus 70, 7 minus 70. Then again you can come to here 666 available, 6 minus 7 minus 1, so negative values are not accountable in the UNIX, so all are nil permissions. This is what exactly user masking. Just I opened administrator prompt here. In front of the administrator prompt we can see some change owner, change group, group add, group del, like this super user commands we try to observe. First we can see change owner, how to change the ownership of a file. First CHOWN, change owner, manual pages, online manual documentation, change file owner and group, option owner group, and several options available. -C important, -H important, and come down -R and -V. As I said earlier also, verbose and recursive. These are the common options available while we are working with the change owner. First, I am giving a file cat. I am creating a post file. It is post box text file. Control D. ls-l. Observe, common permissions available, all are common one. Now here root is the owner. First one always represents owner of the file. Second one always represents group of the file. First, root is the owner. Who created the file means root created. This ownership I want to transfer to another programmer or another test engineer or another user. That time we are using CHOWN, change owner. So first you need to check how many users existed here. You want to check how many users existed. Just you can go to ls, all users available in the home directory. ls home directory, you can say home directory inside whatever the users available displayed. Available Oracle, Raj, Raj5, Raju capital U, Red Hat, UNIX cell, X guest. These are the users created. Now I want to take Red Hat is the user. I want to assign change owner -C, as I shown already changes, and new owner name is Red Hat. Existed owner name is the root and file name is post. P is the capital letter. Press enter. ls-l perfectly get executed. So hereafter this file accessible by Red Hat user. Like this we can change permissions from one user to another user. Good. Now we can observe how to add a group. By using group add, we can add a group. First observe the manual pages of group add. Man group add. Create a new group. Very simple command and simple options. Forcefully we can execute, or and help also we can observe. Q, exit from there. Now I am adding group add. Group name is I am adding Naresh Technologies. A new group I am adding. Click on group add. Naresh Technologies successfully added. Now this group I want to assign to my file. My file name is post. Using which command? Change group. Change group -V, verbose. If you want you can go for man change group. Always manual pages available with a clear and options available. Q, exit, and I am giving here ls-l. Now chgrp change group -V, verbose, or -verbose, anyone we can use, right? -V. I am saying here the new group name is Naresh Technologies. Naresh Technologies. File name is post. Hit the return key. Yes, perfectly. ls-l. So this file is related to Naresh Technologies group. Owner is Red Hat. So like this we can change with hash prompt. That is important. Administrator, super user having all these permissions, all these rights. Now after this we can observe change owner, change group, group add, all these we did. Like this we can do user add to add a new user. We can create, means we can add a password by using passwd command. And once installation session video completed, there I shown already how to create a user, how to assign the password to new user. These are the admin level. And admin level commands: power off, you want to switch off your computer through command prompt. And same available halt. Halt is different, power off different. Before you are going to shut down or before you are going to power off, we are putting first system into halt mode, means ready to off or shut down in safe mode. And halt also same. Next one, reboot available. Reboot is nothing but shut down and again you can restart. This is a command reboot. All these are super user level commands. And SU, switch user. Right now I am the administrator. From administrator to I want to move to user. Imagine my username is, for example, Red Hat. So switch user, press enter. It is moving to $prompt, means normal user. Again I want to come back to my administrator prompt. Then it is asking compulsory permissions or password also. Now I want to change to root, and observe now, password compulsory. Yeah, a super user changing to normal user, password not required. But a normal user changing to super user, password mandatory. And I am entering that password, and we can observe. Yes, converted into hash. This is a super user level prompt. Now after this, we can try to observe some more link related commands. These only we are calling UNIX linked files. What are the linked files? Let me explain on the board first in detail. We can observe these linked files first. What is a link? In Unix operating system, link is nothing but logical relationship between files. We can perform always link to an existing file to a new file. We are unable to perform between two existing files a link. In Unix operating system, links are classified into two types. Number one, hard links. These are popularly known as default links. Second one is symbolic link. First one is hard link. Second one is symbolic link. This is popularly known as soft link or soft linked files. It is a default, it is a soft. Alias names also we can see. Default linked files, soft linked files. Now first we can observe hard linked files information. Now what is hard link? Whenever we are applying hard link between several files, what are the characteristics we can able to identify? First one, a linked file, mainly a hard linked file, every updation reflected vice versa. For example, file 1, file 2, file 3, file 4, file 5. Here 5 files available. I created a hard link. So if you are updated file 4, remaining file 1, file 2, file 3, file 5 will be automatically updated. Means every updation reflected vice versa. But you never see hard linked files any kind of color property, or as I said in the starting video sessions, linked file symbol is @. These two properties were unable to observe here, but easily we can identify because a file characteristic starting with L. So L indicates soft link or symbolic link files. So this L is available, and generally hyphen means normal file. So whenever you are creating symbolic link, hyphen replace with L. So it is indicating that one. And how these files are reflecting each other updation wise. So what about if you remove? If you remove, all these are actively participating, only independent. If you are updating, these are actively participating, vice versa updation. So updation wise dependent, and unlinking wise and removing wise dependent. Means if you unlink, if you remove, that file only affected. If you update, the dependent all files updated. So this is what exactly. Now we can observe file 1, file 2, file 3 areas one by one, or directory 1, directory 2, directory 3. Also you can directory 4, directory 5. Same, whatever the file level operations available, directory level operations also same. There is no big difference here. This is completely related to hard linked. Hard linked files or directories, simple identification is based on inode numbers. Where equal inode number available, those all are related to one group hard linked files or one group hard linked directories. So this is about your hard linked files. Come to symbolic link or soft linked files. These linked files compared to hard linked files, powerful is symbolic. And here color property applicable, light blue as well as symbol also we can able to display. So these two properties are making it is a symbolic linked file. And whenever we are creating file 1, file 2, file 3, file 4, and whenever we are going to link, what is your master file? File 1 based on file 2 created. It is a master. Again file 3. It is a master for this one. So like this 4 files. If you unlink or remove file 1, no file existed. This is soft linked file principle. But if you unlink any child file, no parent file affected. So this is the main principle. Means if you unlink this, these 3 not available. If you unlink this, these 2 not available. If you unlink this, this is not available. If you unlink this, no one affected. Means if you unlink or remove one soft linked file, if it is a master file, all dependent files will be automatically removed. If you unlink a child file, no parent file get affected. It is a main principle of symbolic link. So characteristics light blue, at the red. So these linked files practically with the simple examples we can try to observe. Right, practically we can observe these linked files one by one. I am creating a normal file first. File name is UNIX I am taking. It is UNIX text formatted file. Like that one file I am creating, Control D. ls UNIX file created. ln is the command to link files. Man ln, observe correctly. So link between files. There are the 4 forms available. I am following first one. And link option, target, link name. Even directory also. Directory target also available. Now in the first link, second link they explained very clearly. First -f by default force, interactive already available means it is asking do you want to override that, and symbolic link, and another one is verbose. These are the 4 options frequently we are using, remaining all options common. So ls, ln, link, -v, verbose, UNIX, linux, Linux. So UNIX is source, Linux is target, link, and ls. And if you are going to open Linux, linux, and it is giving UNIX formatted. Now try to append Linux now, cat append Linux. And if you are appending, it is Linux text file, Control D. If you open UNIX, 2 lines available. I said already it is reflecting vice versa. Now if you are going to ln -v Linux, I am linking with Perl, and whenever you say Perl, enter ls. So first is UNIX, UNIX to Linux, Linux to Perl. If you open Perl, how many lines available? Yes, correct, 2 lines available. If I append Perl, how many? Remaining 2 plus 1 means 3 files reflected. Try to append Perl. It is Perl text file, Control D, and available. Now Control D means Perl available. Cat Linux open. Yes, 3 lines available. 3 lines available here. How it is reflecting? As I said, inode numbers basis. See, observe here. 3 inode numbers are equal. Equal in the sense maybe 50,000 files available. One you updated, remaining 49,999 automatically reflected. This is the best advantage of the linked files. So linking a logical relation. So it is available with the help of inode numbers. Now here files available. For example, I am making one directory. Directory name is mydir. It is an empty directory. I want to make a file. File is nothing but Perl with my directory. So press enter. ls you can say cd mydir and once you say ls, Perl available. Say cat Perl, yes, displaying. For example, I am appending a cat Perl here. I am appending inside my directory, I said. Now control D, cd double dot, clear ls and say cat Perl here. Observe you only, last line. Where you updated that one inside the my directory, where you displayed that one in arrays technology directory, means there you updated, it is reflecting here, because these are maintaining equal inode numbers. Where equal inode numbers available, you can say these files are hard linked files. Now file to file, I shown file to directory also. For example, here directory available, my dir, remaining 3 files. Now if you are going to ls-l, long listing format, means all the details will be displayed. Now I want to use unlink. What is unlink? Man unlink. Unlink is call the unlink function to remove specified file, not a linking. We are removing the file. So now we can see unlink file name come out. Now clear, say un unlink. What is the original file? Yes, Unix. If I unlink Unix, Linux, Perl, my directory, all are perfectly available, because inode number basis, all hard linked files unlink independently affected, update dependently affected. Now if I say enter, yes, and Unix, sorry, Unix is capital letter, no issue, and make it yes, els, unlink. Now that file is not there. Open remaining files data, yes, perfectly available, there is no doubt here also, and Linux, yes, perfect data available. Now if you are going to unlink, that particular file only affecting that one. So unlink means removing the file. So link, hard linked files, unlink, hard linked, unlink also. Unlink, I made for example Perl, yes, ls. cd, my dir, ls available. Open cat and Perl. So my words perfectly get executed. So if you are unlinking, this is always independent. Now we'll try to observe same files with different kind of symbolic linked files. Compared to hard linked files, symbolic always superior. It's a color property available as well as symbol property available. If you want to say ls-l, and here you can observe ls, you can observe, and cd double dot ls-l, and you can d, because there is no link here. Links are not there, linked file already directory. You want small l here, simply ln-v Linux, and you can say hello ls-l and available, because soft linked files showing L starting. Hard linked files identification, I said inode numbers only. So where inode numbers equal available, these are the hard linked files. Now I am moving to soft linking files or symbolic linking files. Yeah, symbolic link files we can observe. I am creating a file again. File name I am giving JS. It is JS text file. Simple. Control D. ls. ln-s means symbolic, v means verbose, and js I am giving to AJS. Press enter, ls-l. Now it is available very clearly, light blue color. ls-capital F, yes, @ available. @ indicates and light blue indicates these are the symbolic linked files. At the same time, L also we can able to find out here. L is nothing but symbolic link. All the characteristics very clearly. But here inode numbers never equal. Inode numbers never equal. And I said one principle also. Here master file is JS and linked file is this one. If I unlink master file and AngularJS, link will be broken and ls, and it is giving broken link symbol. And if you try to say anything cat AJS already available, but it is saying sorry, no such file are, but file only just externally visible, but there is no data and no file externally. So this is soft link or symbolic link. Now we can see between directory to directory we can observe. For example, I am creating mkdir hello directory. Now ls ln -sv hello and hi. Yes, both are you can observe now. ls created. Now cd hi, yes pwd my current directory hi. I am creating a file is and wishes. I am creating one file. Once I create, it is wishes text file. Wishes text file. Control D. cd double dot come out and clear ls cd hello. Observe correctly. Wishes available. cd double dot cd hi ls wishes available. Where you created, where it is reflected, because these are the linked directories. There you created is reflecting here. Here you created reflecting there. For example, rm I said wishes removed here. So wishes, sorry, W is the capital letter. Now W. Yes, cd double dot. Go to cd hello and ls. So it is not displaying. So this is a kind of link between directory to directory, file to file. But symbolic link is compared to hard linked file most gentle. In real time industry we are using as per our requirement, but more we are concentrating on symbolic link or soft linked files. Characteristics light blue and @. Hard linked file inode numbers are equal. Thank you for watching my videos. For more videos catch me on youtube.com/nareshit video channel.